Hey y'all. Today's objective is solving non-linear system of equations. You did in Math 1 probably a whole unit on solving a system of equations when both of the equations were linear and the two lines intersect and that was your solution. Or you did it maybe by elimination or substitution. So sort of the same thing. We're solving nonlinear systems. So you might have a linear equation and you might have a quadratic equation. And so we have to solve them to find out where they intersect. It's going to look, most of the time, it's going to look like a quadratic equation and a linear equation, and the 2 points of intersection would be your solutions. If the quadratic equation is concave down and the linear equation goes through it, you still would have two solutions. So just a little bit of pre-solving. We've been solving quadratic equations, but we haven't solved anything that looked quite like this. So if you have a situation, you are going to cross multiply. So in this example, negative 2x equals 128 divided by x. You are going to cross multiply like it was a proportion. So negative 2x times x is going to give me negative 2x squared. And then this would be over 1. 1 times negative 28 gives us negative 128. I divide both sides by negative 2, and I'm left with x squared equals 64. Now at this point, you have to take the square root of both sides. So x is equal plus or minus 8. All right, now here's another one. Sort of like it's a proportion. Pretend this is all over 1. You're going to cross multiply. So 20 times 1 is 20. When I multiply here, it's x times x minus 1, which is x squared minus x. Because you distribute x times x is x squared, x times 1 is x. I move the 20 over, so now I have a quadratic equation. X squared minus x minus 20 equals 0. We've learned lots of different ways to solve quadratic equations, and this one I just factored because I saw that it was easy to factor it. X minus 5, x plus 4. So my solution is x is equal to 5 or negative 4. Alright, and then in C, I have 0.5x squared equals 12.5. There is no cross multiplying, so I divide both sides by 0.5, and I get 25. So I take the square root of both sides, and x is equal to plus or minus 5. Okay? So I know that was really quick, but essentially, it's a different way that a quadratic equation looks when you have variables on both sides. So once you cross multiply, you put them together, you end up having a quadratic equation. Alright, so the first example was this long word problem about number of something and cost of something. I can't remember what P stands for, so I just decided to give you the basics. It's this whole word problem, and ultimately it wants to know when are these two going to be equal? When is this equation going to be equal to this equation? So you set them equal to each other. 1200 over P equals 160 minus 4P. Now again, you can look at this as if it were a proportion, and you're going to cross multiply. 1200 times 1 is 1200, and P times this, you're going to distribute. P times 160 is 160P. P times 4P is 4P squared. Now I move my 1200 over, or I move this over. Let's move this over so I can have a positive P squared. I'm going to move both of these over, so I'm going to have a positive P squared, and I'm going to subtract minus 160P plus 1200 equals 0. Now I have a quadratic equation that I know what to do. If you want to go straight to quadratic formula, you can. I'm going to factor out a 4 because we want to find out when they're equal to each other. I'm going to factor out a 4, and I get that. And then in order to get 300, you could complete the square, you could factor. I think in order to get 340, I think 30 times 10. So 30 times 10 would give me 300. And negative 30 times negative 10 would give me positive 300 and a negative 40. So I'm going to factor, whoops, and you can use a quadratic formula. You can do completing the square. I just know that 300, the factors of 300 are 30 and 10. Like, factors of 3 would be 3 and 1. So, like, the reason I factored this, because I kind of viewed this as p squared minus 4p plus 3. And I knew that would be x minus 1 and x minus 3, so then I just used the same thought process. I come over here and I set that all equal to 0, and when I set this equal to 0, p could be 30, and when I set this equal to 0, p could be 10. That means that for values of p is 30 and 10, these two parts are equal. Now this real world problem has something to do with what it is, and I'm sure one would be better than the other. But in this example, we know that these two equations would be equal when p is 30 or when p is 10. Alright, example 3, or 2. Well, I wrote example 3, but it's supposed to be example 2. Consider this system of equations. I'm giving you two equations. How many solutions do you expect? Well, we talked about this. This is concave up, so my quadratic would look like that parabola, and then I have a linear that would go through it. So I would expect 2. It's possible that you could have one solution if it intersects only at one point, or it's possible to have 0 solutions if they didn't intersect at all. We would expect 2 solutions. However, you could have 1 or you could have 0. So now we're going to find the solutions. I set them equal to each other. To find the solutions, you're going to set them equal to each other. And we need to get everything on one side. I'm going to minus 3x, and I'm going to minus 25. When I do that, I get 2x squared plus 11x minus 40 equals 0. Now I have a quadratic equation, and you can use the quadratic formula, you can factor it, you can complete the square. For this specific example, I factored. So I came over here, and I did 2 times negative 40 is negative 80, and I want to get 11. And then you have to figure out what are the factors of negative 80 that when you add together, you can get 11. And I know that since this is negative, one's going to be negative and one's going to be positive. And I believe it's going to be, this is a positive 11, so 16 and negative 5. So when you multiply those, they get negative 80. When you add them, you get 11. So 2x squared minus 5x plus 16x minus 40. So I'm showing you this factoring, but you can factor or you can do the quadratic formula. I'm going to factor out of x, and I get 2x minus 5. And since I want 2x minus 5, right here I need to factor out an 8. So x plus 8 and 2x minus 5, which are going to give me my solutions of negative 8, because if x plus 8 equals 0, that needs to be negative 8. And this would be a 5 over 2. 5 over 2. So like we said, 2 solutions, negative 8 and 5 over 2. Alright, this is long, so pause it, copy it down. Each year, Wake Forest organizes a rally. Based on previous years, the organizers decided that the income comes from ticket sales, and it's going to be I of T, income of ticket sales, is related to the ticket price, T, by this equation, 400T minus 40T squared. So this is one of our equations. Cost, so obviously if you're going to put on a rally of some sort, it's going to cost something. Cost is also related by this equation. So A, what ticket price would generate the most income? What ticket price would generate the most income? So we would need to find the maximum of the income. And then write a rule that will predict the profit. The profit. So in this first one, we would need to take this and we would need to find the maximum. So we would need to put it in vertex form. Negative 40t squared plus 400t. So notice I just put that first. I would need to factor out a negative 40, and this would be 10t. Now notice my positive became a negative because I factored out a negative 40. I'm going to complete the square. So I would take negative 10 divided by 2, negative 5, square it, and I would get 25. Negative 40 times 25. Negative 40 times 25 is, I don't have my calculator. So negative 4 times 25 is negative 100. So it would be negative 2,000. So then I would have to add 2,000. 25 times 4. So, negative 1,000, not 2,000, 1,000. Okay, sorry. All of that to say, in vertex, so my vertex, to do the maximum, my vertex would be 1,000. Which means, what's my question? What ticket price would generate the most income? So $5 ticket price. $5 of ticket price would generate the maximum. 5 ticket price, and this would be your income. $5. So write a rule that predicts the profit. Well, the way you find your profit of something is you take your income and you have to subtract your cost. Your income minus your cost. Anyone knows that if you put money into something, you have to get that money back, and then you make profit. So our income is this. And I'm going to put the negative 40t squared plus 400t. And then I'm going to subtract my cost, which is this, minus 400 minus 40t. So when you subtract it, I hope you see this, when you subtract these two negatives, this is really going to become a positive. So minus a negative 40 is really going to be a plus 40t. So that is going to affect here. Negative 40t squared plus 440t minus 400. So that would be your profit. Now all it's asking is for a rule. It's not asking us to solve it. So we have a rule for a profit. So what price would generate the most income? $5 ticket prices. You don't really want to go more than $5. That will affect your income. And then this is the rule that would predict the profit of our ticket sales.